Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to be looking at First Hop Redundancy Protocols. We'll be discussing default gateway limitations, router redundancies, steps for router failover, and finally, First Hop routing protocol options. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. In a traditional network, we have a switch that we have right here. So this is our switch. Then we have all of these end devices, a PC, a server, another server, lots of end devices all connected into that. All of these devices, their exit on and off the network is a default gateway. Each one of these devices have a default gateway programmed in. What the default gateway is the exit off of their network that's connected to a device that connects them to other networks. In this diagram right here, we're looking at this connection right here. This is the default gateway. The default gateway exists on their LAN. It's part of this local area network, but it's on a device that connects to other networks. And that device that does that is a router. So this is our router here, and then it connects to other devices. All of these end devices, they only have one default gateway. They're only set up with one default gateway. The problem comes in is what happens if this connection to the default gateway goes down, or what if this router goes down? These devices back here can't get out. There's only one point coming in or out. This is a bottleneck. This is a single point of failure. The limitation for a default gateway is most devices only have one set. Even if we have redundancy set up in our network. Here we have a couple layer 3 switches that have IP addresses from the layer 3 switches. They can get onto other networks, but this PC down here, this end device, only has one default gateway set. That's all the operating systems, Windows, Linux, Mac, all these proprietary devices, IoT devices, they only set one default gateway. And when your default gateway goes down, R1 right here, this connection went down. R1 goes down, something happens here that doesn't allow PC1 to get out to the network. They can't do their job. They can't make the connections and do what they need to do. Even if they have the redundant path here from this switch up to R2, and then R2 can connect to the network and to the internet, they can't get there because the operating system only has one default gateway set. That's the limitation. How do we take care of this limitation of the default gateway being a single point of failure? We implement what we call a virtual router. And what we do with this virtual router is we take more than one router, 2, 3 routers, and we make it look like one router in software. So you have physically you have at least 2 routers. But in the software, what we do is we make it look like one router. And that virtual router has its own IP address, has its own MAC address. And what really happens is those physical routers, they all share that same IP address, that same MAC address. They share it between them. But because it's virtual, the virtual device gets that. Now, when a host looks up the MAC address of the default gateway, what it gets is that MAC address of the virtual router, because that virtual router has its own MAC address, has its own IP address. That way, the host device can send traffic to that address of the virtual router. Then, once it gets that that virtual router, which is actually a shared IP address on the physical machines, on those physical routers, they can actually process that and send it off. That physical router then forwards it on. The end user never knows that this is happening. It's all transparent to them. To get this router redundancy, what we do is we run a protocol. There's a handful of these protocols. There's several of them. Some are better than the others. Some are used in certain areas. But what this protocol, this redundancy protocol does, it determines which router should take the active role in forwarding. You have two routers, and one of them is the active one. One is going to be a standby. And so this protocol determines which one is the active one, which one will actually be sending that data back and forth. And then that protocol determines, hey, the active router went down, the standby router then becomes the active one and starts forwarding that traffic. Once again, end user never sees this. The end devices, they never know this is happening. Yes, if you time it right and you happen to hit it just perfect, you may have to reload your web page. You may have to reconnect, or the page may take an extra second to load in. Worst case scenario. But 99 times out of 100, the end user, the end device will never even know this happened. This is what we refer to as first hop redundancy, because a hop on a network is every time you change a network, you hop on from one network to another. That's a hop. And every time you go through a router, that's what you're doing. You're hopping through that router, one network to another network. And this is first hop redundancy, because your default gateway is that first router you get to. That's the first router you get to, and we're giving you redundancy on your default gateway, on that router that connects you from your local area network to the bigger network. I hope you're liking this episode on first hop redundancy protocols. Do you have any questions on the first hop redundancy protocols? Leave me a comment below to let me know what your questions are. Also, you can visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Most protocols go through a process to establish which router is the active one, which one is the standby. There's multiple ways to do that. A lot of them base it off of IP addresses. Whatever protocol you choose has its own election process. And what happens is we have two physical routers. And right here in this diagram, the left router, that's a physical one. The right router, that's the physical one. And these two routers run some sort of redundancy protocol. It goes through an election process, generically we'll call it that, and it'll figure out which one's the active, which one's the passive. And after that election process is done, one will be labeled active. And so that active is actively forwarding data. After the election process, the other one will be a standby one. Could go by a couple of names, but we'll call it standby. Depending upon the protocol, standby is usually what it's called, but it could be something else. These two devices then share an IP address. As you set up this redundancy protocol, you go in there and say, okay, use this IP address. In this example here, the left router has 192.0.2.1 as its address. The right router has 192.0.2.2. Just two consecutive IP addresses. They have to be different because each device needs a different IP address. But what you do inside the routing protocol is let's set the virtual router to its own IP address. And here's the third IP address, 192.0.2.100. This is virtual. It doesn't exist anywhere physically. It exists there. And along with that, it also gets a MAC address. And so when we do the ARP process, we can forward packets from our PCs to that first device. This virtual router. And so when you see diagrams like this, a lot of times you'll see three routers, but you have to understand we only have two physical devices and the other one's virtual. It doesn't exist. You can't go up, you can't touch that one. And this virtual router, and all it is the two physical routers are sharing this IP address. And so they share this IP address, the two physical routers. And one is forwarding traffic, one is not forwarding traffic. And the routing protocol has some sort of communication built into it, that the active and standby routers, they're communicating back and forth. Their communication back and forth, back and forth. And at some point in time, when the standby doesn't hear anything from the active router anymore, it assumes that active router went down. When that active router goes down, the standby then says, okay, the active router is no longer up and running. What we're going to do is we're going to transition from a standby, and now we are the active router. And we will be the ones forwarding data on and off of our network. When we have that failure, when we have a failure, whether it's the connection into the active router, whether it's the router itself, just something here is stopping traffic from going through. What happens is that the standby router takes over as the new forwarding router. And a lot of times you'll see people draw this diagram out this way, that they'll draw the 3 diagrams. And once again, the 2 outside ones are the actual physical ones. The inside one is our virtual one. And what they say is the traffic goes from the end device up to the virtual one. And then the virtual is the software that is actually running between those two. That software then routes it to the correct one. And so after the left one failed here, it's going to route that traffic. That protocol is going to route the traffic to the right one, that new forwarding router, and then it can go on to the internet or the bigger network in general. There are a handful of first hop redundancy protocols out there. Probably 2 of the more popular ones here are the hot standby router protocol and the hot standby router protocol for IP version 6. The first one, where it doesn't have a version of IP, that's for IP version 4. HSRP is a Cisco proprietary first hop redundancy protocol. Cisco proprietary. Now, that's a double-edged sword when I say that. If you are an all Cisco shop, you have all Cisco networking devices on your network, this is a great protocol to have. Cisco makes sure that their proprietary protocols are polished, they work great, they have lots of features, and it just works. It's a really good protocol. But because it's Cisco proprietary, it only works with Cisco equipment. So if you're in a mixed environment where you have other routers besides Cisco routers on there, HSRP won't work. HSRP is designed to allow transparent failover of that first hop IP version 4 address. HSRP has a group of devices. One gets elected as the active, the other ones get elected as standby. And when there's a failover, the main one goes down, the standby then becomes the active one, and it all happens without the end user knowing it. HSRP for IP version 6, yes, once again, is a Cisco proprietary first hop redundancy protocol. Same functionality of HSRP for IP version 4. What we use for HSRP IP version 6, we look at using those link local addresses. We have the link local addresses that are assigned to the physical devices. We create a virtual device that has a link local address, and traffic is routed to there. We have the active, we have the standby. They do failovers, and how they update themselves is they use router advertisements. The Virtual Router Redundancy Protocol version 2, it's an open source, it's a non-proprietary election protocol that allows multiple connections to the internet to happen. It's just like, it's very similar to HSRP, where we have multiple routers that connect into there. We create a virtual device, goes through an election process. Here they create masters and backups. When the master fails, the backup takes over. Virtual Router Redundancy Protocol version 2 is IP version 4 only. When we get into the Virtual Router Redundancy Protocol version 3, that's where we do IP version 4 and IP version 6. Multi-vendor environment, and it's more scalable than its predecessor, the FHRP version 2. Gateway Load Balancing Protocol is another Cisco proprietary protocol. What this does is it protects traffic from a failed router or circuit. and it also allows for load balancing between the connections. HSRP, VRRP, that uses one connection or the other connection. What the Cisco proprietary gateway load balancing protocol does is, yes, we have the failover, but it also load balances between it. Gateway load balancing protocol, without specifying the IP version, is for IP version 4 only. GLBP for IP version 6, well, it's for IP version 6. And finally, we have the ICMP router discovery protocol. That's specified by the RFC request for comment 1256. It's a legacy first hop router redundancy protocol. It allows IP version hosts to locate routers that provide connectivity to other non-local IP networks. It allows them to get that connection. IRDP, once again, is legacy, so it's being phased out. Companies are going away from it because the other ones are better. HSRP, VRRP, GLBP, those are a better protocol than the IRDP. The fun thing about IRDP is it's an abbreviation that contains an abbreviation. If you look, IRDP, I stands for ICMP. And so there's an abbreviation in the abbreviation. It was my pleasure to provide you with this wonderful episode on First Hop Redundancy Protocols. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.